Hi, Assalamualaikum. Welcome to the video. And today we are going to present our wireless local area network group project. Okay, so for the wireless local area network, it enables devices to connect and communicate wirelessly in today's world. So wireless communication has become an essential in our daily lives. By eliminating the need for physical cables, it offers users the flexibility and convenience when accessing networks and the internet. So for the project's background, the building consists of three floors that will be covered by access points to cater network connectivity for the users in the building, particularly those who require wireless access. So the key components of a WLAN or wireless access point or routers, client devices such as laptops, smartphones, and tablets, and the network infrastructure that connects to the access points to the internet. So access point acts as a central hubs, allowing wireless devices to connect and access the internet. It also allows mobility and flexibility by eliminating the need for physical cable, which is a significant advantage over traditional wide networks. So that users can stay connected while on the move by accessing the internet from different locations within the coverage area. So it can accommodate multiple users simultaneously. That can lead to improved overall performance, better data rates, and better coverage. So for problem statement, overloaded access point can happen when there are too many devices connected to a single access point. The building typically hosts hundreds of students and staff, each using various devices like laptops, smartphones, and tablets. When an access point hits the device limit, users may face slow internet speed or even total network unavailability. This issue usually happens during peak times, like when all the students or the staff's devices are connected simultaneously to the network for maybe classes or exams. Other than that, we have interference, which is also a significant factor for wireless networks, as the access point and other devices operate within the same radio frequencies. The main interference would be the physical obstruction, such as thick walls, that will weaken the signal strength, resulting in reduced speed and bandwidth for the users. Next, we have insufficient coverage. That can be the biggest problem, where it creates dead zones that lead to users not accessing the network or experiencing weak signals. With the impact of physical obstruction and the placement of the access point, it struggles to ensure consistent coverage, which lead to less productivity. So the objective of this project is to ensure uninterrupted wireless connectivity across all the areas, and then to implement strong security measures in order to protect the user data and also to design a better solution for the problems mentioned. So project significance, it has the potential to enhance various aspects of our environment, enabling students, lecturers, and staff to communicate effortlessly, access information, and collaborate seamlessly. Next, we will dive into the chapter 2, which is the literature review. So, in review of WLAN technologies, a WLAN is a type of local area network that uses high frequency radio waves instead of wires to communicate between devices. WLAN are based on the IEE 802.11 standards, commonly known as Wi-Fi. So the coverage of an 802.11 network is affected by data rate, volume of network traffic, environmental obstacles, interference, transmitter power, antenna direction, and connectivity. Next, we will review the hardware for this project. So first, we have the access point, which is a network device that allow interoperability between wireless and wireless network. Next, we have the switch, which controls the transfer of information inside the network, identifying the throughput MAC address of an incoming frame and then directing the frame safely to its destination. Next, we have the routers, which is used to manage internet access and network traffic, ensuring optimal performance with quality of service. In the review of software for the WLAN, we have three things. So the first one is firewall, which is to safeguard against unauthorized access and cyber threats. Then we have the anti-malware. We use anti-malware software to protect against viruses, trojans, worms, and ransomware. And then we have the anti-spyware. The software targets spyware threats, which can capture and transmit sensitive information without the user's consent.
Assalamualaikum warahmatullahi wabarakatuh. My name is Wan Amir Hazieq. So we're going to talk about chapter 3, WLAN design. For network requirements, before designing the WLAN, we establish the minimum network requirement to ensure a strong and stable connectivity. For the strength, signal strength should be at least negative 70 decibel milliwatts on all floors. For the SNR, should be at least 25 decibel. For clear and stable connection, the data rate should at least be 12 megabit per second for floor 1 and at least 10 megabit per second for floor 2 and 3. For the access point, it should be at least 4 access point to avoid network congestion. For the latency, also known as ping round trip time, should be maximum of 150 millisecond to make sure the quick response time. The packet loss should not exceed 0%, meaning there should be no lost data packet during transmission. Why all of these are very important? If any of these requirements are not met, user may experience slow internet speeds, high latency, or drop connection during peak hours. Going to the next one is network capacity. We analyze the number of devices connected to the network on each floor. On floor one, we estimated it's about 30 smartphones, 28 laptops, and 19 tablets. On floor two, we expected the device were 28 smartphones, 24 laptops, and 10 tablets. On floor three, with the estimated count was 31 smartphones, 28 laptops, and 15 tablets. This data help us determine how many access points were needed to provide stable connectivity without overloading any single access point. For the next slide, we're going to talk about WLAN coverage areas. The coverage area refers to how much space is covered by the Wi-Fi signal. For our WLAN design, the floor 1 has coverage area of 523 square meters. Floor 2 and floor 3 each have a coverage of 448 square meters. The challenges in the coverage for physical obstruction, such as walls and furniture, can weaken the signal strength. Interference from the other electronic devices can reduce the network efficiency. We totally address these issues by strategically placing access point to minimize that zone. Now, let's look at the floor plan access point placement for both of these floor 1 and floor 2. For floor 1, we place 4 access point in the strategic location to make sure we can get the full coverage across the area of 523 square meters and also to minimize the signal interference from walls and furniture. This can distribute the network load evenly to prevent any access point from getting overloaded. For floor 2, we followed a similar approach, covering for 148 square meters with 4 access points. This design can ensure strong and stable connectivity on this floor, especially in high traffic areas such as lecture halls, classroom, and common spaces. For floor 3, the design is slightly different due to layout constraint and user density. The total coverage area is 448 square meters, quite similar to floor 2. However, we carefully place 4 access points in strategic position to also get the high speed connectivity for students and for all the faculty members to minimize that zone, particularly near walls and corridors. By dividing all access points across the 3 floors, we guarantee strong network coverage, stable connection, and minimal interference throughout the building. Okay, now we going to talk about the logical network diagram, which represent how our WLAN is structured. Our design include Cisco AP185 access point, which are dual band, meaning they support both 2.4 gigahertz and 5 gigahertz frequencies. Each AP can handle up about 25 users. The SSID, or the service set identifier, is UITM Wi-Fi student for student and UITM Wi-Fi staff for faculty members. The network follows WPA2 encryption, which stands for Wi-Fi Protocol Access version 2, to gain the secure connection. This logical design guarantees efficient data flow, strong security, and smooth connectivity. So we're going to be the end of the chapter 3 for special consideration and optimization. To further optimize the network, we implemented the following strategies by increasing the numbers of access points in high traffic areas like classroom and hallways. The next one is using non-overlapping channel to reduce interference between access point. The next one is balancing the network load to prevent access point from getting overloaded. And the last one is regular network monitoring to detect and resolve issues quickly. These improvement will make sure the stable, high-speed network for all users.
Alright, Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Wafiy bin Muhammad Rupli, and now I will be explaining about chapter 4 for result and analysis. So, without further ado, let's go. Alright, so for the first one, it will be for signal strength and coverage. So, in wireless communication, coverage and signal strength are crucial variables. So, signal strength, which is commonly expressed in decibels, is the power of the wireless signal that a device has received. So while a weak signal can cause a slower speed or failed connections, a stronger signal often produces a faster and more dependable connection. So conversely, coverage indicates the region which the in the in which the wireless signal can be efficiently received. So a device can connect to the network further if the coverage area is better or and larger. So even with a strong signal, coverage might be diminished by obstructions like walls, interference, or distance. So as we can see here, for signal strength and coverage for floor one. So for before the optimization, floor one face weak signal strength in certain areas due to improper placement of access points and physical obstructions like walls. As we can see here, by each class, there are walls separating them. So the signal strength in some zones drop below the threshold, which is the 70, causing the dead zones and unreliable connections. So after the optimization, the placement of four access points was adjusted to ensure the consistent coverage throughout the floor. So these adjustments improve the signal strength significantly by eliminating a few dead zones and providing a strong connection in all areas. So for floor 2, before the optimization, the signal coverage on floor 2 was inconsistent with areas experiencing weak signals below the 70 dBm threshold. This was primarily due to APs being poorly positioned and interference from physical obstacles. So after the optimization, we repositioned the four APs and adjusting to their power levels, ensured that to ensure a more fair or uniform coverage with no dead zone remaining on the floor. So for floor 3, or the highest floor. Similar to the other floors, floor 3 initially faced issues with weak signal strength and incomplete coverage. So particularly in areas obstructed by walls The signal strength in some zones was below the suitable threshold. So after the optimization, the APs or the access points were repositioned to address these weak spots and improving the coverage and ensuring a strong signal throughout the floor. Alright, now I will be explaining about SNR or signal to noise ratio. So, signal to noise ratio is measured in decibels, indicates how much the wireless signal is audible above the background noise. So, a high signal SNR indicates that the signal is much stronger than the noise, so allowing for a more dependable and clear communication. Slow speeds, interference, or lost connections can result from the noise that is near or stronger than the signal. So, as indicated by a low SNR, because excessive noise can drown out even a very strong signal. Um, so, as we can see here, SNR is a critical component of a wireless performance. So, for the SNR on floor 1, it was initially low in many areas, so it's falling below the required decibel threshold. So this was caused by the interference from overlapping Wi-Fi channels and electronic devices. So after the optimization, uh, we improved the channel management and reduced the transmission overlap increase. So SNR value across the floor, resulting in a reliable and interference-free connectivity. So for the next one, the SNR on floor 2 was inadequate in several regions before the optimization. So a high background noise and interference from overlapping Wi-Fi channels were the key contributors. So after the optimization, SNR values improved significantly thanks to the better AP placement, reduced power overlap, and proper channel assignment, ensuring stable connections across the floor. Alright, now for floor 3, before the optimization, the SNR values on floor 3 were low, particularly in areas with significant interference. So the values will fell below the 35 decibel threshold, causing slow connections and drop packets. So after the optimization, the SNR improved significantly due to proper access point placement. So it will reduce the overlap and the use of dual band access point, which is 2.4 gigahertz and 5 gigahertz, resulting in a more reliable communication across the floor. So now I will be explaining about the signal strength by access point. So for floor one, each of the access points were evaluated. So before the optimization, certain APs were overloaded, while others had underutilized capacity. So it was leading to unable signal strength contribution. So after the optimization, the APs were redistributed to ensure a balanced load and consistent signal strength throughout the floor. So it can meet the required threshold, which is the 70 dBm. So for floor two, the it will be the same case as floor one. The signal strength of each AP or access point was tested before and after the optimization. So initially, some APs provided insufficient coverage due to poor placement and resulting in weak signal in some areas. So following the optimization, APs access points were placed strategically to ensure a balanced signal strength to meet the required threshold throughout the floor. And for floor 3, some APs provide a weak signal in areas from the location leading to dead zones. So after the optimization, each AP was carefully positioned to maximize their own coverage and eliminate weak zones. So all APs for each floor now meet or exceed the required signal threshold, which is the 70 dBm. So for the network performance, before the optimization, High latency and frequency packet loss and low data rates, which is below 12 Mbps, were reported on floor 1. So after optimizing the AP placement and after optimizing all the access point placement that we have done, as we mentioned earlier, and channel configuration the latency was reduced to less than 100 ms, and the packet loss was eliminated, and data rates improved exceeding the rate 12 mbps requirement. So it provided a seamless connectivity for the users on that floor. So for floor 2, before the optimization, floor 2 suffered from high latency and inconsistent data rates. So packet loss was also a significant issue. So after the optimization, the latency was reduced to an acceptable level, so below 100 ms, and the packet loss was eliminated, and data rates improved to exceed 10 Mbps requirement. So it ensures a smooth and also a reliable connectivity, the same one as floor one or the ground floor. And finally, for floor tree. So prior to the optimization or before the optimization, floor tree experienced a high latency, packet loss, and poor data rates. So after the changes that we have done, the latency dropped below 100 ms, and the packet loss was eliminated, and the data rate increased to exceed beyond 10 mbps. So it delivers a consistent and reliable performance for users on this floor. So so as you can see here, before the optimization of loss encounters the same problem. So they experience weak signal, inconsistent coverage, low SNR, and also poor network. So after the optimization, we improve in areas such as APs access point placement, and also we add some APs where it matters the most. So it improved the channel management and power setting, resulted in a stronger signal strength and higher SNR, and also a better performance across all flow. So the dead zones were eliminated. The latency dropped below 100 ms, and also the packet loss was eliminated.
So we're going for the last slide. We're going to talk about conclusion. So the first one is successful network deployment. The project successfully established a strong and strategic wireless network infrastructure to ensure reliability connectivity for users. The next one is comprehensive approach. Began with a true understanding of the background, challenges, goals, forming the foundation for design and implementation. Insight for the simulation. Simulation results provide important insight into WLAN throughput performance. However, limitation exists in measuring other key performance metric requiring careful consideration in assessment. The next one is future ready network. Leverage advanced technologies and best places in WLAN deployment. The infrastructure is now well equipped to support current operation and future technologies advancement. The next one is enhancing productivity and communication. The scalable WLAN enhance productivity and enable smooth communication within the building. The last one is ongoing monitoring and maintenance. Continuous monitoring and maintenance are essential to sustain optimal performance. Such a quick issues resolution and necessary adjustment will make sure the peak efficiency and security. So that's all from us for this project. Assalamualaikum and thank you.